What is Green's theorem? Okay, in this topic, we will cover regarding the relationship between the integral of closed area and double integral as well. Note that C is a closed piecewise smooth curve which is oriented counterclockwise, while R is the region enclosed by the curve. It might be difficult to integrate over the irregular curve C, hence we use Green's theorem to make it easier.
Yes, I see just now. Here is the movement of the curve C. As we can see, it is moved counterclockwise. Okay, counterclockwise of the curve C. And then we have the equation. Let's take a look at the equation. Here got line integral for C. Integration of C where we have fxy dx plus gxy dy equal to double integration of r dA. Okay, dA, we have to find dA. And integrate g with respect to x minus f with respect to y. So here is the equation to solve the problem regarding the Green's theorem.
So, the application of Green theorem. Application of Green theorem can be used in many fields such as in classic mechanics and electrodynamics. Electrodynamic fields, the Green's theorem can be used to calculate Maxwell equation and the energy of the steady currents. In classic mechanics field, it can so the definition of mechanics is the calculation of various momenta in two-dimensional shapes and axial symmetry. Green theorem in classic mechanics can be used to calculate moment mass, center of mass, and the third, it can calculate moment of inertia, and lastly, it can be used to calculate the Kepler second law. Question 1.
For applying Green theorem for water flow a rectangle, water flow a spring located at origin, the velocity of the water is modeled by vector v x y 5x plus y x plus 3y milli per second. Find the amount of water per second that flow across the rectangle with this coordinate of the rectangle. Okay, first coordinate is -1, 3. Second is -1, -2. Third is 1, -3. Fourth is 1 and -2. From the question given, first we need to write the Green theorem formula. Is integrate f s x y dx plus g x y dy equal to double integral df per dx plus dg per dy dA. Okay, from the question we get we have the equation is vx equal vxy equal to 5x plus y x plus 3y. So vxy equal to 5x plus y x plus 3y. So we divide for this for fx, this for gx. Let's fx equal to 5x plus y, df per dx equal to 5, y equal to 5, we differentiate 5x, so we get 5. So gs equal to x plus 3y. So dg per dy we get 3. So we substitute the answer to the formula. Double integral df per dx plus dg per dy dA. Double integral df is 5, dg per dy is 3 dA. So we get double integral a dA. So dA is area of the rectangular. Okay, second step we need find dA. dA is area of rectangular. So here we get a coordinate of area. So we need to find length and width for we get area for rectangular. So the length of the line formed by joining the coordinate is -1, 3 and -1, -2. So we want to find the length, so we take the coordinate -1, 3, -1, -2, or we can choose 1, -3, 1, -2 for the length. So length is equal to 3 minus -2. So negative we positive, 3 plus 2 we get 5. The width by joint of the line joining, for the width we take -1, 3, 1, -3, or we can take -1, -2, 1, -2. So 1, -3, -1, 3. So width equal to 1 minus -1. So 1 plus 1 we get 2. For the area equal to length multiplied by width. So length is 5 multiplied by 2 we get 10. Okay, we get the area of the rectangular. So we can substitute the area in this. So we get a new paper. Double integral 8 dA. So 8 is constant, so we move out 8, double integral out dA. So dA we already get 10. So 8 multiplied by 10, so we get 18 square meter per second. So the question asks, find the amount of water per second that flow across the rectangular. So we get 80 square meter per second water flow across a rectangular. That's all from me.
Question 2.
From analyzing the question, we can get that David is skating along a circle with radius 2 in counterclockwise direction, and Sandra is skating along a circle radius 3 in also counterclockwise direction. Then we get the function, and also we are going to use Green's theorem to calculate work done. Now we proceed to plot the graph. Once we've plotted the graph, the next step is to use Green's theorem to calculate work done. So the general formula for Green's theorem is this. In order to use this formula, we need G and also F given from the function. F will be x squared y plus 10y, and G will be x cubed plus 2xy squared. Now we are going to differentiate d with respect to y, and we get x squared plus 10. Next we differentiate g with respect to x. 3x squared plus 2xy is the answer we get. Next we are going to substitute this answer into the equation. We can reduce it. Next we can denote x squared plus y squared as r squared, so we reduce the equation again and become 2r squared minus 10 dA, and dA we are going to denote as r dr d theta, so the new equation will be 2r squared minus 10 bracket r dr d theta. Since the circle is different radius, so the limit for David and Sandra will be different. So for David, r will be from 0 to 2 because of the circle with radius 2, and theta will be 0 to 2 pi because of the circle. And for Sandra, r will be 0 to 3 and theta will be 0 to 2 pi. Now we are going to calculate work done by David, and for that we are going to use this equation, and this equation can be expanded, so we are going to do that. Once that is done, we are going to substitute David's limit into the equation, which is 0 to 2 pi and also 0 to 2, and then we proceed to integrate. We get 2r power 4 over 4 minus 10r power 2 over 2 with limit 0 to 2. Once we have done that, we get 0.5 r power 4 and 5 r power 2, same limit. Then we substitute the limit into the equation. Once you've reduced this, we get negative 12, and we integrate negative 12, we get negative 12 theta, and we substitute 2 pi into the equation, we get negative 24 unit work done for David. And now we are going to calculate work done by Sarah. We are going to use the same formula. Then we are going to substitute the limit with Sarah's limit, which is 0 to 2 pi and also 0 to 3. And now we are going to integrate, and we get 2r square minus 4 and 10r square over 2. Now we are going to substitute 3 and 0 into the equation. And then we get 40.5 and 45, which will give us negative 4.5. And then we are going to integrate the negative 4.5, we get negative 4.5 theta, and then we are going to substitute 2 pi into the equation, and we get negative 9 pi unit work for Sandra. And when comparing work done by both individual, we can say that David did more work than Sandra.